Hello, AP Environmental Science, and welcome back. We're going to talk about waste generation and waste disposal, just what you've always wanted to talk about, trash. Wow, take a look around. This place is a dump. All right, I'm just kidding. In the 1930s, the United States, even though the public was totally not happy about this, it opened dumps around the country and, of course, continue to do so when they're growing. And so the most convenient locations for them are in cities where there's a lot of municipal waste. And they became holes in the ground that created by removing, soil and sand and other earth material that was there. And we use that usually for construction purposes. When people filled these holes with waste, the sites became known as landfills. And opening dumps are now rare in developed countries. They still exist in the developing world, but they're now considered to be a health hazard. So we're going to examine some basic designs and implementations of landfills, and of course look at incinerators. In this unit, you're going to describe the goals and function of the solid waste landfill. Whoop, whoop, what a dump. And then you're also going to explain and design the purpose of a solid waste incinerator, which you would think would be simply just to burn stuff, but apparently there's more to this. All right, landfills are the primary destination for all your trash. In this figure, you see the United States is the third of our waste is recovered through this RRR, reduce and reuse, recycle type of thing, but more than half of it is discarded. So the remainder of this is converted into energy through incineration. And in the U.S., MSW that is not diverted from the waste stream ends up to become either buried in a landfill or it's incinerated. Initially, there were a few concerns about this material ending up into a landfill, and those responsible for collecting and disposing of this solid waste in landfill, they did not recognize that there'd be so many problems associated with landfills, like components of waste that was generated that was harmful. Who'd have thought we screwed that up too? Okay. All right, so some landfill basics. Leachate is the water that leaches through the soil waste, which is removed by various chemicals and compounds that people come in contact with. They did not recognize that this, of course, was going to be harmful when the landfill was located near some sensitive features like aquifers, rivers, streams, drinking water supplies, and other places humans inhabited. So today, some environmental scientists believe that we should not use landfills pretty much at all. And in later times, we're going to talk about discussing some alternatives through waste disposal. But although landfills are still a component of solid waste management in the United States, we can make them much less harmful if they have been as they have been in the past. So if we just follow some basic rules, examine some landfill basics, we can see how we can help this problem. And so many people believe that a great deal of biological and chemical activity occurs in landfills. They imagine that organic matter is sitting there breaking down in the landfills and is shrinking over time, and then this material is then converted into carbon dioxide or methane gas, which is released into the atmosphere. All right, so the University of Arizona has challenged many of these misconceptions by using these archaeological tools to examine modern-day garbage. Some of his colleagues at the University of Arizona have found that newspapers with headlines still, after 40 years, they're still legible when you pull them out of a landfill. So are they really decomposing? Providing that little decomposition has happened and has taken place there, what's actually really going on? Today, it's widely accepted that decomposition takes place only in the area of the landfill where the correct mixture of air and moisture and organic material is present. So because most of the area does not contain that necessary mixture because it's underground and not exposed to air, the landfill probably is going to remain the same and just completely trapped in time. So given that the lack of decomposition actually happens in a landfill, the design and construction needs to happen with some certain care. So in the United States, some municipalities, we also call them sanitary landfills, they are engineered with certain facilities designed to hold waste and have as little contamination as possible to the surrounding environment. So these sanitary landfills are interesting. They are constructed with a clay plastic lining on the bottom, and so clay is often used because it can impede water flow and retain positively charged ions material. And a system of pipes is then constructed below the landfill and collects the leachate, which is sometimes recycled back into the landfill. And finally, a cover of soil clay, which is called cap, not to be confused with crap, is instilled when the landfill then, of course, reaches its own capacity. So rainfall and other water inputs are minimized because excess water into the landfill causes a greater rate of this anaerobic decomposition, and so consequently it causes more methane gas to be released. And although with a large amount of water entering the landfill from both MSW and rainfall, there's a greater likelihood that some of the water will leave the landfill as leachate. And leachate is not captured by the collection system. It basically is going to leach into some nearby soils and groundwater. This leachate is tested regularly, though, for its toxicity, and of course, if it exceeds a certain standard, then I guess the landfill operators then have a different set of requirements, and then they have to treat it as toxic waste. But once the landfill is constructed and it's ready to accept municipal waste, perhaps the most important component of operating it as a safe modern-day landfill is basically controlling all the inputs that go into the system. So the materials designed for a landfill are those least likely to cause environmental damage through this leachate and this generating methane. So those are materials, composite materials. They're usually made of plastic and paper. These are things like juice boxes that are made for children. Those are good candidates for becoming, difficult to recycle, like aluminum materials that are like combo materials, and other copper type of materials too. Those can contribute to toxic leachate. In addition, some of these metals, they're also valuable for recycling. So we should also just do that. Aluminum and copper, we've talked about before, that should really never go to a landfill, period. Plus, it's just more valuable to recycle it. Glass and plastics are both chemically inert, which making them suitable for a landfill when we've reused them and recycled them as much as possible. So toxic materials like household cleaners, oil-based paints, automotive additives, motor oil, antifreeze, consumer electronics, batteries, anything that contains a substantial quantity of metal should not be deposited into a landfill, period. All organic materials like food and garden scraps and yard waste, they have a potential to produce a high amount of methane, and so of course those should also not go into a landfill. I'm kind of still wondering what's left here. So the municipalities add to a landfill periodically these things where they compact the volume into what they call cells. And so these cells are like little individual pieces that are individually covered with soil, and they maintain their own type of little system. And it's also usually to reduce odor. And so when a landfill is full, it must be closed off from the surrounding environment. Basically it needs to be entombed. So a municipality or any sort of private enterprise that does this can do this, construct a landfill, is a huge cost. And so the cost to recover it is usually done by charging, people a fee. That's what they call a tipping fee, because each truckload is put into a scale, and then after the municipality is weighted, it is tipped into the landfill, hence the name tipping fee. So tipping fees at solid waste landfills average about $50 per ton in the U.S., and although certain regions, like of the Northeast, fees can be like twice of that or more, these fees create an economic incentive to reduce the amount of waste that goes into a landfill. And so many local recyclable companies will start to charge based on the actual cost of the actual mass of the actual items. Okay, so if tipping fees become too high and regulations, they kind of become too stringent, usually local people will encourage it'll encourage people to dump illegally, and that can also not be good either. So this kind of has to be, this tipping fee has to be regulated and watched somewhat. So a lot of things go into considering the sitting of a landfill, which means, where we're going to designate its location. A landfill should be located in a soil-rich and clay environment that reduces the migration of contaminants, right? It should also be located away from rivers, streams, and other bodies of water, especially those used for drinking water. And a landfill should be sufficiently far away from people, populated centers, so especially because there's so many trucks that go into transporting waste and stuff. And so animal scavengers and things like seagulls and rats and all that can produce another risk to people, so it's important to hide it. A landfill sitting away from highly controversial and sometimes political charged areas is also important because that's not good for voting. It's not going to get you votes if you put up a landfill directly in the middle of the city. So landfill sitting has been the source of considerable environmental injustice in our history. People with financial resources and political influence, they often adopt this popular saying, which we say, "not in my backyard," or NIMBY, as it is affectionately called by my generation. It's an attitude about landfill sites. Because of this, a site may not be chosen next to people because it may not meet safety criteria, and in other opinions, because neighbors lack the resources to mount an effective opposition against putting a landfill in. So Fort Wayne, Indiana is an example of the Adams Center landfill that was located in a densely populated, low-income, and predominantly minority neighborhood. The University of Michigan Environmental Justice Study quotes that there was this hydrologist and professor at Purdue University, and he said that on a scale of 1 to 10, with 10 being the most geologically ideal site, that the Adams Center landfill rated a 3 and maybe a 4 because the site did hold a substantial risk of water contamination. And so when the communities surrounding this landfill learned about the report that had come out, they basically protested the renewal of the federal permit, and they fought the expansion of this landfill, in both on the city and the state level. So ultimately, in 1997, the decision was made by the Indiana Department of Environmental Management that they got that landfill closed. But essentially, the lesson here is that they put it in that area without proper research. So all those sanitary landfills, we've seen that there's an improvement over opening just like any old dump site. They present some problems. Locating landfills near populations that do not have the resources to objectify them is a problem. And no matter how careful the design and engineering, there's always a possibility that leachate that we talked about from this landfill will contaminate some sort of underlying adjacent waterway. And so the EPA estimates that virtually all landfills in the U.S. have some sort of leachate problem. Even after the landfill is closed, the potential to harm some adjacent waterway is still there. So the amount of leachate that has leached out is it's really impossible to kind of determine, how that's going to happen in advance. So to get an idea of how much is generated from a landfill and how much that we know is going to be collected, we have to do some math because we can predict a little bit about this. So do the math section on how much leachate might be collected in your packet. The risk of human and ecosystem health from leachate is pretty much uncertain. Most of the public has this perceived notion that the landfill contaminants pose a great threat to human health, although the EPA has ranked this risk fairly low compared to other things like global climate change and air pollution. Methane and other organic gases basically generate decomposed organic material in landfills, and they do release greenhouse gases. So, when solid waste is first placed in the landfill, some aerobic decomposition takes place, but shortly after the waste is compacted into like a cell and then covered, and then most of the oxygen is all used up, and so it becomes entombed, the anaerobic decomposition begins. And so this process generates methane and CO2, which are both greenhouse gases, as well as other compounds. And so this methane also creates this explosive hazard, right? Because not only is it bad enough that it smells, but it also can explode. All right. So the methane also creates a reason for landfills to be ventilated so that the methane does not accumulate over this highly explosive quantities. In recent years, more landfill operators are using a source of electricity to kind of heat the landfill and ignite the gas. And an even more desirable environmental choice would be to keep the organic material out of the landfill completely and use it for composting.